Hi again, everyone. This video is for the regression activity that you should start on Monday and really work through by Wednesday when a second activity will open up. This one is a little less scary, I think, than doing Cronbach's alpha for the first time, but let's take a look and I'll pull this up. So this is available for you on Canvas in the Unit 3 activities folder right now. So you can get started as soon as you wish. You'll notice right away that there are a lot of tabs available to work on here. The first two are really some math practice using the equations for z-scores and for calculating Pearson's R in order to make predictions about somebody's scores for one measure based on their scores for another measure. And so both of these first two tabs walk you through an example first and then give you some practice. Don't stress out too much about this, right? You should be able to use these equations to manipulate numbers. But if you're not sure about these, right, please post questions on the discussion board. This shouldn't be something that causes a lot of stress. So I'll just walk you through this first example here. So all these questions use this basic data up here, right, where we're going to use z-scores to kind of answer regression style questions, right? So we have some data here that says for a self-esteem measure, we have a mean of 3.5 and a standard deviation of 0.25. And for IQ, we have a mean of 100 and a standard deviation of 15. And the relationship between these two measures by Pearson's R is 0.60. Right, so we have that summary data there. And then there's some questions where we can predict one score from another based on just that information alone. So for question A, so this is where it walks through the whole example for you. Right, it says Jane scores 3.5 on the self-esteem scale, right? What IQ would you predict for her just based on this information we have up here, right? So this walks through what we would do. First, you need to convert the self-esteem raw score we have for Jane to a z-score. So, right, in this case, we know z is somebody's score minus the mean divided by standard deviation. Right, you may have already guessed based on the fact that Jane's score is the same as the mean that we'll get to 0, right? But doing the math, 3.5 minus 3.5 is 0. 0 divided by 0.25, right? Our standard deviation for self-esteem. The z for self-esteem for Jane is 0. The next step is we need to predict the IQ z-score, right? And so based on one of the equations, right, that's in the slides and in the chapter, we know that to get zy, right, this is equal to r times zx. So in this case, we know that r for this relationship is 0.6, zx is 0, 0.6 times 0 is 0, right? So the prediction for Jane's z-score for IQ would also be 0. Then, now that we know the z-score for IQ, we can convert back to get the raw IQ score, right? So z is still equal to score minus mean divided by standard deviation. In this case, right, the mean is 100, standard deviation is 15, and the z-score for IQ for Jane is 0, right? And if you solve that in math, you get to that equaling 100. Right, and this example is easy because it's the mean, right? So you already have that up there with z-scores of 0. But now there's a few more examples where you have to do a little bit of math, right? It's just a little bit of practice, right? So you can work on that. And the second tab is just using regression equations to solve for somebody's predicted y-score, right? So in this case, given a regression equation, then if you have somebody's score for the x, you can plug that in to the equation for x and solve for y, right? That's really straightforward. If you have any questions or concerns about that, again, please post on the discussion board. Preferably send me an email, right? We can work on that. Then you have two tabs of larger data sets where you need to, right, make some scatter plots, run some regression analysis in Excel and in Jamovi, right? And so there's two tabs for you to practice on that. And so I'm going to show you how to do this in Jamovi and just a little bit of Excel on a different data set so that I don't give any of this away, and this can serve as some good practice for you. So let's pull up this data here. And so we have, in this case, 10 subjects, small sample size. We have their IQ and some anxiety score, right? So let's jump to Jamovi. I've copied this over into Jamovi as well, right? So again, IQ and anxiety are the data that we have to work with here. And so if we're going to do regression, like I talked about in the regression video, and like you read in the chapter, right, this is underlined by correlation. So let's go to PSYC. We're going to go to estimate correlation, right? And again, this is where it's important that we think about what we're trying to predict. In this case, let's try and predict someone's IQ score based on their anxiety. So we're going to put IQ as the variable that we want to predict, and we're using anxiety to predict that, right? So if you plug that in, you're going to see what you saw when we were working with correlation, right? You're going to get Pearson's R, the CI on R, and you're going to get a nice scatter plot, right? Exactly what we want to see. Built into this same analysis are options for regression as well. So we're going to select these options, right, and take a look at what we get from there. So we're asking it to give us the regression line, the CI on the regression line, and also prediction intervals for anywhere on X as well, right? So there we have our nice regression line there, right? We can see kind of the outer limits of these predictions. And below, in addition to showing what it did before with our correlation and the CI on R, now we also have our regression equation down here as well. So that's really useful. The other thing that you're going to want to be able to do, especially for the homework, is use a data set to build a regression equation like this and then test new subjects based on their X value, what we're going to predict them on their Y value, right? So in this case, let's say we have somebody that comes in with an anxiety score of 8, and we want to see what we predict their IQ to be based on the regression equation we have. So there's an option down here, right? Given an X value, make a prediction on Y, right? So we said their anxiety score is 8. So if we put in, all right, based on X, what will we predict their Y to be? In this case, you can see that we would predict their IQ to be 92, right? And it gives you this at the bottom as well. Sometimes it's hard to read on the graph itself, but at X equals 8, right, we would predict Y to be 92, and it gives us our 95% prediction interval as well, right? In this case, 59 to 126. So in this little example data set here, right, this is a pretty low relationship, not a very good predictor because it's close to 0. And this prediction interval on estimated Y is really wide, right? If you were using this to predict someone's IQ, anywhere between 59 and 126 is not a very useful predictor, right? But you can have that information for any of the data sets that you work with. If you're asked to predict somebody's Y score based on their X and give a prediction interval, you can get that here really nicely as well. So as usual, Jamovi is pretty easy for getting that information. Let's jump back to Excel, right? So you can, right, calculate Pearson's R in Excel. You've done this a lot already, right? You could do it step by step if you want to do that practice, and you can use the Pearson's R command in Excel to get that as well. I'm not going to show you that again now because you've already had a lot of practice with that, right? One of the other things that you should be able to do, like we also practiced, is make a scatter plot in Excel. And so what I want to show you now is how to add a regression line and get the regression equation if you had to do this in Excel, right? So I've already created a scatter plot here, right, with our axes labeled. And in this case, right, IQ, there's not really an upper limit, so it's okay to set it based on the data. And I didn't tell you what the scale of the anxiety score is, so don't worry about formatting that in this example. When you know what the scale is, right, like we talked about, it's always good to scale your X and Y axes based on that. To get the regression line, you want to right-click on any of the dots in your scatter plot, and then you should see an option to add trend line. If you do that, you'll get the line. That's your regression line. And it's also going to open up a menu where you can format the trend line. And if you scroll down to the bottom of that menu, you'll see options to display the equation on the chart. So you can do that, right? So we get our regression equation there, y equals 0.41x plus 88.9. Right? And you can see that's the same as here. Jamovi flips the order, right? So they do 0.41 times x on the right side and 88.9 on the left, but that's the same equation, right? X is in the right place. So to get the same equation in both places, you can always check yourself that way, right? And then the other thing that you can get in Excel is you can get R squared as well. So that's another component of this chapter that you should be aware of. So R squared is just R squared, right? Straightforward. And it tells us the proportion of variance that can be accounted for Y by X, right? So it gives us basically how much of a predictive value are we getting from X in order to predict Y, right? So it's almost a percentage of the variance that's explained by X. So that's something useful, and you should know what R squared is, at least that it gives you that type of information. So based on that, you should be able to walk through the two examples in this particular activity, right? So you have some data set here. You need to run the correlation, get the regression equation, practice it in both Jamovi and Excel. And then you can also calculate the residuals of prediction for each participant, right? So you can actually use that regression equation to do that. It's a lot of math practice. You know, it's not crucial that you do all of that practice, but it's something that you should be able to do, right? And then the second data set is a huge one. So you'll notice hundreds of subjects in this case, right? Big data set, so you should expect some really nice small confidence intervals on this one. But the big question here is whether SAT scores or high school GPA is a better predictor of college GPA, right? So you can run the regression analysis for SAT and college GPA and high school GPA on college GPA, right? And then based on that, you should be able to say which one is a better predictor of college GPA, right? And again, if you have any questions on any of this, please post on the discussion board or send me an email and we can work through it. So that's it. There will be another activity posted on Wednesday that's kind of a survey practice activity. And I'll think about whether there's a video for that or not, but most of those skills are things that you will have done before, so I might just set it up on the discussion board in terms of the things that you want to think about for that. All right. Again, as always, stay home, stay healthy, and I'll talk to you again soon.